Okay, let's revise our pulley questions next. So here we've got two objects. One usually will be heavier than the other, 5 in 3 Ks. We're given gravity and we want to work out the tension in the string, okay? And also the downward acceleration of the 5K object. So obviously the heavier one is going to take over. So we would think that overall the direction of motion will be something like this. And this is sort of an important thing to think about to start with. So first of all, if we look at this 5 kilo side, we're obviously going to have gravity taking it down, so we'll call that 5G. Tension working against it. So the overall mass times acceleration, so the overall mass times acceleration, okay, remember it's going down overall. Gravity will work with it, tension against it. Now we'll go over to this side and this guy is going up. So the overall acceleration 3A, gravity will be working against the motion. So instead of writing 3G, we'll write negative 3G, okay? Because it's the opposite direction to the motion. Tension will go with it, so we'll add the tension this time. So you can see it's sort of flipped around on each of those. Now if I add those two equations, I'll get 8A equals 2G and the T's will cancel. So acceleration when I divide it by 8 will be G on 4, which equals, with it putting in our 9.8, 2.45 meters per second squared. Okay, one thing you might notice is that one of these we have to add and one of them we have to subtract. So that's something to keep in mind. Okay, how do I find the value of T? Well, I could use either of these here. I'll use this one. So I could say that T will equal 3A plus 3G. And we know A is 2.45. And we know G is 9.8. And we'll work that out and it'll give us the tension. And I guess if you have time, if you plug it into the other one, verify that, you might feel a little bit safer with that question. In our final example, we're going to look at inclined planes. And if you do physics, this should be fairly simple for you. If you don't do physics, make sure you ask me in class where all these things come from, but I'll go through briefly. So imagine we've got some object sitting on an inclined surface or an inclined plane. Obviously, gravity will still work on it. It should drag it directly down. We'll also have the normal force, which is always perpendicular to the surface, which stops it falling through. Additionally, we'll have some friction, which will stop it or slow it down, going down the slope. So there are our main three forces: gravity, the normal, and any type of friction. What we want to do then is we want to break that up into the overall force, usually going down the plane. It could reverse if we're towing it up. So going down the plane and then in terms of the normal. So what you might like to remember, especially if you're not physics, is the force down the plane is always mg sine theta. The force that balances the normal, mg cos theta. Okay, and again, you're going to ask me where I got that if you don't know that, if you don't do physics. So in our first example, we've got a 4 kilogram box, M, on an inclined plane at 20 degrees from the horizontal, theta, and it's on the point of sliding down the plane. So what it means is friction will be balancing this sliding force because it's not quite moving, just on the verge of it. So we're going to draw a diagram to represent the situation. So basically, we're going to always draw something like this, but we're going to put in the values we know. We know theta is 20. We know M is 4. We're not given gravity, so we'll leave it as G. So you'll have something like so. I tend to still put, okay, so maybe still put your normal, your friction, unless it says there's no friction, frictionless surface, and your gravity, and then break them up into these. Notice I do dotted lines because they're not actually the force. They're just the forces broken up into its components. Okay, so once we've drawn that, it's pretty easy to answer the following questions. find the size of the force acting down the plane. Now, we haven't been told anything about friction, so we're just going to ignore that for now. So maybe just get rid of it. The force down the plane is just your 4g sine 20. If there was some friction operating against that, we would minus the friction. So I'm regretting now drawing the friction on there. This will always be very clear in the questions. The size of the normal force, again, we're ignoring friction. Worry about that later when you do extension 2, and it will be 4g cos 20. And that's all it is, okay? So as I said, if you're just doing extension 1, maybe just rub that out there. I feel deep regret. Rub it back out here as well, and we'll just do frictionless surfaces.